having any
Recording in
smoking habits or
progress.
not, whether you are having a drinking habit or not, and whether you are having any pre-existing disease or not. And based on that and your age, based on your age and based on your gender, that is either female or male, based on this, it is going to give you the what is the premium amount, whatever the health insurance premium. For any policy, some premium we have to pay, right? That premium amount, it is getting decided. Now is that for example, if you belongs to some kind of Hyderabad, your premium amount is going to increase, and if you belongs to Delhi, means your premium amount still increases. Is there any rule like that? Wherever you stay in India, it is same. The premium amount is not going to change, whatever the part. Okay, just inside the, if you go for the hospitals, inside that it might, rules might be changing. In Delhi, the room price will be different. The hospital, whatever the fees, doctor fees will be different. That fees will be different. Inside the hospital will be different. But from the health insurance, everything is same. From insurance perspective, everything is same. Similarly, here, if you are predicting the expenses are not dependent on the whatever the region you are having. So here, the region, whatever the region is there, southwest or southeast, it is not depending on the region. The expenses are not depending on the region. So since they are not depending on the region, I'm simply dropping that particular column, right? And I'm going to remove the duplicates also. And after removing the duplicates, now how many records I'm having is 1337, means one record is duplicated. Original data is 1338 minus 1. Now I'm having 1337, right? So the total number of records are 1337 comma 6, right? Because I have dropped the region column. Now here, the gender, whatever the gender is there, the gender I'm going to replace females with 0 and males with 1. Why? Means if you apply one hot encoding also same na. For example, gender column is there. Okay, this is the gender column. In the gender, female, male, male, female, 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 male, something you are having like this. Now, if I have applied the one hot encoding, because this gender column, what is this gender column? Gender is a nominal data or ordinal data? Nominal. It is a nominal. For nominal data, what type of encoding we have to do? Nominal encoding. That is nothing but dummy encoding. Now, dummy encoding, if I do here, first I'm going to get the female category, followed by male category as per the alphabetical order. Now, since it is a female record, 1, 0, male record, 0 and 1, 0 and 1, 1, 0, 1, 0, 1, 0, 0 and 1. So instead of this data, I'm having the data like this, right? Now, out of this, I'm going to drop first is equal to true, because dummy variable trap. If you are having two categories, we have to remove one of the category. I'm just writing the first variable drop. If I drop the first variable, now the entire data set was converted to zeros and ones. Now, what is your original data? Your original data is gender. This is the gender column. After dropping this one, now what happened? You got this one only. In this case, what is female was replaced with 0, male was replaced with 1. If you do one hot encoding also, no problem. If you do with respect to get dumb is also no problem. If you do that directly replace also no problem. If you have only two categories, if you apply dummy encoding, label encoding, replace, 3 of them will give the same to same answer. Anything is okay. There will be no difference. If you have only two categories, dummy encoding, label encoding, and replace, everything will give the same answer. Sir, generally label encoding is alphabetical order, right? Yes, female and male. First female will be given as 0 and male will be given as 1. If you apply the dummy label encoding also, answer is same. If you apply the replace also, answer is same. If you go with dummy encoding also, answer is same. There will be no difference for two categories. If you are having more than two categories, that is 3 categories or 4 categories are there, in that case, the difference you'll see. Why? Because nominal encoding will convert to more number of columns. Here for 2 categories, how many columns it is going to convert? 2 categories are there. Inside that, only 2 categories are there. 2 categories will be converted to how many categories? How many columns? Only 1 column. After dropping 1 column, you'll have only finally 1 column only, right? The output is 1 column. If you do directly label encoding also, 1 column only answer. If you do the replace also, answer is 1 column only. So that is the reason. But whereas if you are having in your original data set, some kind of 4 categories are there. 4 categories are there. Now here, if you apply one hot encoding or dummy encoding, then how many columns you are going to get? 3 columns you are going to get, out of which one of them is you have dropped also. Still you'll have the 3 columns. Column number 1, column number 2, column number 3. 3 columns it is going to convert. This will be converted to 3 columns. But if you do the replace, only 1 column it will be converted. If you do label encoding, it will be converted to 1 column. How 1 column will be equal to 3 columns? So in that case, if you are having more than 2 categories, in that case only the difference will be there. If you are having exactly 2 categories, there will be no difference. Whatever you apply also, will be no difference. For 2 categories, no need to check whether it is ordinal data or nominal data also. Answer will be the same. For more than 2 categories only, the difference will be there. Is that clear, guys? Now, similarly, the smoker, I'm having no and S. So I'm just replacing with no with 0 and S with 1. Right? Now, and just observe what is the data pre-processing I have done. First, in the data pre-processing, within the data pre-processing, step 1, I have dropped the region. Remember this. First, I have dropped the region in the data pre-processing. Step 2, what I have done? Duplicates. Drop the duplicates. Next, you have replaced the gender column. You have done the replacement in the gender column. That is encoding of the gender column. Replace means nothing but encoding. You have done the encoding of the gender column by replacing female with 0 and male with 1. And next one, you have encoded the encoding of smoker, this column, by replacing with no is equal to 0 and S is equal to 1. Okay. So this is which you have done in the data pre-processing. Is that clear? In the data pre-processing, what are the things I have done? One, I have dropped, that is region column. Next, I have done the encoding for the gender column. After that, I have done the encoding for the smoker column. If multiple records are there, I have dropped the duplicates. If multiple records are there, I am going to drop the duplicates. Drop duplicates is applicable when you are having the multiple records. If only for one record, for that duplicate will not be there, right? Only one record is there. For that duplicate, where it will be there? Right? Done. Now, later, once this is completed, now I'm going to take X is equal to df dot drop of expenses. Apart from the expenses, remaining column. What are the remaining columns are there? What are the remaining columns? What are the remaining columns? In the DF, what is DF? Your DF is this one. In the DF, already you have dropped the region before itself. Now, you are dropping the expenses. Now, within the after dropping this one, whatever the balance is there, that is age, gender, BMI, children, and smoker. These 5 columns you are going to consider in the X, and expenses you are going to consider in the Y. Whatever the Y is expenses. Let us see X and Y. This is the X and Y. Let us check the X variable. Let us open the X variable. This is the age, gender, BMI, children, and smoker. Right? And coming to the Y variable, if you want to see your Y variable is nothing but expenses, all the expenses values. Now I'm going to do the train test split of test size of 0.2 and random state of 9. Okay. And Xtrain. I'm going to take the Xtrain. Now, what is my Xtrain data? What is Xtrain? So it is going to have age, sex, BMI, children, and smoker. This is the order. And total, how many records? 1336 records, out of which 80% are used for training purpose. 20% of the data is used for testing purpose. So 80%. Let us calculate what is the 80%. 80% means 0.8 into 1336. 0.8 into 1336. 36 or 37? Original data consists of 38 and 37. You have to take 1337. So 1337. So you have got 1069.6. If you make round figure, it is 1070. So 1070 records I am going to consider in the training. 1070 records are used for training purpose. Let us see what is the dot shape. Let us ask the dot shape. It will give with respect to 1069 records it is taking for the training purpose, and for testing purpose, X test, whatever the X test dot shape. 268 records. 268 records it is taking for the testing purpose. Now, here I am having the modeling. Now, what I'm going to do? Modeling. What is modeling means? From sklearn.linear model, import the ridge regression. And I'm going to store in a model name called as ridge underscore base. The name of the model is called as ridge underscore base. And I'm going to fit on Xtrain comma Ytrain. And I'm going to print intercept value. And I'm also going to print the quotient values. Whatever the quotients are there, I'm going to print the quotient values. This is called as modeling. After modeling, what I'm going to do? I'm going to do the predictions using that model.predict on Xtrain, model.predict on Xtest. Once the modeling is completed, next what we are going to do? Evaluation. Next one is evaluation. In the evaluation, what we are going to calculate? Train R square, test R square, and cross validation score. And based on the evaluation, we are going to do the model selection, whether it is a good model or a bad model. Earlier, the same thing in the multiple linear regression. If you observe here, in the multiple linear regression, separately I have taken in the modeling 5 lines of code. That is from sklearn.linear model, import linear regression, and model.fit on Xtrain, Ytrain. These 3 lines. What are the 3 lines? And one is for intercept and one is for quotient. The same thing I'm writing here. After that, this is 1 line. Here, prediction on Xtest, 1 line. Calculate the test accuracy is 1 line. So 5 lines in the modeling. In the modeling, 5 lines. Test prediction, 1 line. And test R square. Test R square, 1 line of code. And after that, test R square, next predict on the train data. That is train prediction. Whatever the train prediction is there, that is 1 line. After that, train R square. This is 1 line. And next cross validation, CV. For CV, I have to import the cross validation score. So 2 lines. So total here in the machine, this MLR, I have taken separate cells. But total, what is the total number of lines? 5, 1, 6, 7, 8, 9, 10. Total 10 lines of code. This 10 lines of code in the mesh in multilinear regression, I have taken in a separate cell. Cell number 1, cell number 2, cell number 3, cell number 4, cell 5. In 5 different cells I have written. But the same 10 lines of code here I'm bringing in 1 cell only. That is the difference. Count the total number of lines. That one and this one will be the same. Whatever I have done there, here also I'm doing the same. Okay, I'm predicting that predict on Xtrain, predict on Xtest. After that, I'm calculating train R square, test R square, and CV. Instead of doing in a separate cell, I have copied everything in a single cell. That's it. Is that clear, guys? So once I have done this one, now you can see here, the first one is intercept value. Okay, let us print this one as intercept value. Intercept. And this is the coefficients. So now you can see here, this is the intercept value.
And this is the quotient values. How many quotients you are going to get? 5 quotients. Why 5 quotients? Because in your xtrain, how many shape, what is the shape is there? 5. In the xtrain, what is the data you have given as the input data? That is, first one is age, gender, BMI, children, and smoker. So beta 1 is belongs to age column. Beta 2 is belongs to gender column. Beta 3 belongs to BMI. Beta 4 belongs to children, and beta 5 belongs to smoker. So total 5 quotient values you are going to get along with one intercept value. 5 quotients and one intercept. So that is the order. Order also important. B1, beta 1 belongs to age only. It can't be with others. So whatever the order you have given for the training on the xtrain, that is the order it is going to make. Right? So this is the beta 1, beta 2, beta 3, beta 4, and beta 5. This is the one. So now, if you observe, this is the intercept values and these are the quotients, and you got the train R square as 75% and test of 70% and cross validation of 74%. Now, if you observe here in this entire things, what is the alpha value it has considered? Betas, okay. Betas, it is going to do d by dx of that, and from that it is going to do the beta values. Okay. What is the alpha? If you observe the alpha, if I click on the shift tab, here the alpha value by default it is considering as 1. That is the default value. Okay, so here I have written the ridge regression with default parameters. Default means by default it has applied the alpha is equal to 1. But I don't want with alpha is equal to 1. I want to try with the different alpha values. I want to apply for different alpha values and I want to identify the best alpha value. So then what I'm going to do means just I'm applying the for loop for I in list of alpha values. What are the list of alpha values I want to try? I'm going to take all the list of alpha values, that is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 7, 8, 9, 10, 1, 1.1, 1.2, something I want like this. Just I'm trying with the different alpha values. So now just we are going to apply for different alpha values. We are going to try and we are going to get the best alpha value. Sir, here means are we going to do the manually the 0.1, 0.2, 0.3? Are we going to write manually? No need to write manually. For that we are having with respect to range function is available, right? And for range function and along with the range function, for example, np dot arrange of 0 to 10. I'm going to take 0 to 10. Now what happens? I'm going to get for 0 to 10 means by default 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you are going to take the range function, or for each and every value you can add 0.1. So for that what we are going to do? First we are going to take the for loop or while loop. I'm applying the while loop. While x is less than or equal to 10, x is equal to x plus 0.01 or 0.1, and each x value I'm going to append into an empty list. L is equal to this one. L is equal to L dot append of x. Every value will be appended. Every value will be appended. First I'm going to take while x is less than or equal to 10. Initialization of x is equal to 0. I'm going to take x is equal to 0. I'm going to take and L dot append of x. X is equal to x plus 0.1. Now I'm going to get for every value, it is going to append plus 1, plus 0.1, plus 0.1, plus 0.1 like this. First 0, 0.1, 0.2, 0.3, 0.4, 0.5 like this. Now here, how to select that alpha value? Means whether we have to go with the point wise or which one. And that too, why up to 10 only? Is there any rule up to 10 only? This is the question. Okay. The question would be with respect to how this 0.1 will be selected. And the second question is, what is the maximum value? Minimum value is 0. Okay. Alpha should be always positive. Alpha should be always positive. Okay. And what would be the maximum and what would be the step? This is the question. Now here, this maximum value, none of them knows what is the maximum value. So what we are going to do is first we'll keep up to 10. If the 10 is the best answer, we'll try to increase. Within the 10 only we have got the best answer, then no need to increase. For example, 10 is the best answer means we'll try to increase. Next, we'll try to increase. Similarly, we'll try to increase with respect to this. Okay. Now here the step, whether the step of 0.1, why we are considering only the step of 0.1, alpha will be in terms of called as learning rate. Now the learning rate will have a step of 0.1, and still if you want to try with 0.01, there'll be no difference. If you want, you can check. After the class, you try with 1.01, 1.02 and tell me, have you observed any difference between 1.01 and 1.02? Let us try now only. Why after? Here just you take the alpha, you write alpha. The parameter name is called as alpha. Alpha is equal to 1.01. For 1.01, what is the train R square I have got? 759363. Up to 6 decimals I am considering. Okay. And let us try with this one with 2. Is at least any decimal has changed after up to till 4 or 5 decimals? Any change up to 5 decimals by changing in the 0.01? So 0.01 change in the alpha will not have any impact. So 1.2. So let us try with 1.2. And after that, if you try with 1.3, at least you can find at least a decimal change in something. But even you can't observe that much of change in the 0.1 only least case. For that, still you can't apply the least. No need to apply that much of. So always go with the step of 0.1. Not only here, I'm not explaining only for the ridge only. In the future for lasso, for elastic net, and in the future, we are going to apply that gradient descent algorithm. Wherever the word of learning rate comes into picture, learning rate. Now, what is meant by learning rate means how much it is going to shrunk the quotients, means it is going to decrease the quotients or increase the quotients, the percentage of increase or decrease in the quotients. That here we are going to consider that value you can take with respect to by step of 0.1. Okay. Now what I'm going to do here, by default, alpha is equal to 1. Now just observe here, I'm going to apply the hyperparameter tuning. Hyperparameter tuning in the last class in the polynomial regression, I have shown you how to use by using the for loop. We have applied using the for loop. Now the same thing, I'm going to show you a shortcut called as grid search CV. Grid search CV. Now here, what is meant by grid? What is meant by search? What is meant by CV? 3 of them are there. First grid means given data. Okay, don't write 7 days along with me. Just observe. It will be easy to understand. Search means it identify the best. Identify the best. CV means CV score. Within the given data, identify the best CV score. That is the meaning of grid search CV. Right? Now, here what it is going to do, I am going to give the, in the grid search CV, within the grid search CV, later you can write. Once again, I'm explaining clearly, just observe, because this is going to be common for all the algorithms from now. So grid search CV in the bracket, within the grid search CV, if I import the grid search CV, so just I'm showing you here, I'm going to import the grid search CV. I'm importing the grid search CV, and after importing the grid search CV, whatever the grid search CV is there, grid search CV, whatever the grid search CV is there, I'm going to click on the shift tab. If I click on the shift tab, you can see here, these two are the compulsory arguments. These are the default arguments. If you don't write also, no problem for this, but these two compulsory arguments. Now these two compulsory arguments, out of which the first one is called as estimator. Now what is meant by estimator means model. For which model? Model means which algorithm. For which algorithm? Next one is param grid. The next one comes with respect to param grid. Param grid means parameters. Grid means values. parameter values. Okay. Now, what it is going to do? Just let me explain here. Grid search CV. In the bracket, I'm going to give the estimator. The estimator is equal to ridge. This is my estimator. Param grid. Param grid is equal to alpha. Alpha values, I want to try between 0, 0.1, 0.2, 0.3, 0.4, 0.5. Assume I have taken 6 values. Okay, which is in the dictionary. Param grid should be always in the dictionary, out of which the key name should be the hyperparameter name. And value should be the list of values which you want to try. Now, once you give this grid set CV, in the grid set CV, estimator and parameter grid like this. Now, if you apply this one, what happens in the backend means just it is going to take for loop. For alpha, whatever the name you have given here, that will be taken here. For alpha in, whatever the list of values you have given here, it will take that list of values here. 0.1, 0.2, 0.3, 0.4, 0.5. For alpha in, it will apply like this. For alpha in, and within that, it is going to take model. Model is equal to whatever the estimator you have given here, it will take that estimator, ridge, and within that alpha, your alpha value, whatever the alpha is equal to these alpha values, it will try the list of alpha values. And it will apply the model dot fit on xtrain ytrain. It will apply on fit on xtrain ytrain. Simply to say, here it is going to take whatever the list of alpha values are there. Whatever the alpha values you have given here, the list of alpha values, it will try one after one. It will apply just for loop. After applying the for loop, it will apply the model on the fit on xtrain ytrain. After fitting on xtrain ytrain, now model is ready. That for this model, it is going to calculate the CV score. It will calculate the CV score of the given model on X and Y. Whatever the data you have provided, it is going to apply the CV score with the CV is equal to 5. CV is equal to 5. How it has selected this CV is equal to 5 means in the grid set CV, we have to write that one also. In the grid set CV only, we have to write even that one also. What is the CV it has to apply? So now CV is equal to 5, I'm writing in the grid set CV. So it is going to apply the CV is equal to 5. Now what happens? First time, it is going to take I is equal to 0. First, it will take I is equal to 0, means it is going to substitute alpha is equal to 0, and it will complete the process and it will calculate the CV value. It will calculate the CV for alpha is equal to 0. Next, I is equal to 0.1. It will calculate the CV for alpha is equal to 0.1. Next, I is equal to 0.2. It will calculate the CV with alpha is equal to 0.2. I is equal to 0, CV is equal to value for alpha is equal to 0.3. Alpha is equal to 0.4. Alpha is equal to 0.5. For each and every alpha value, it will calculate the separately CV. And whatever the every CV score it has got, it will take into an empty list. One empty list will be there. And this empty list, it is going to append this CV. Whatever the CV is there, it is going to append this CV. Now total how many values it is going to append? 6 values. Out of these 6 values, which is the highest one, it will identify and that it is going to give the output. So for which alpha value is the highest CV score we have got, it will give the output directly. Indirectly in the backend, it is applying the for loop only. In the yesterday's class, we have done manually this one. In the polynomial regression, I have shown you this one. In the polynomial regression, I have shown you how to apply the for loop and how to change the values and how to append into an empty list. And from that, how to calculate, we have done manually. Now, instead of doing that one, now you can use directly the grid set CV. Both are same. In one example, I have shown you manual calculation. In one example, I'm showing you the advanced one without doing the manual. In the backend, it is going to apply the same thing. Right? Now, see here, in this grid set CV, in this example, estimator is equal to ridge and alpha is equal to 0.1, 0.2, 0.5, 0.7, 1, 10, 50, 100, 1000. Some numbers are there. What are the numbers? Right? Now what I'm going to write? Estimator. Estimator means it is going to take the ridge. Param grid means these are the values. CV is equal to 5. So for each alpha value, it is going to apply the CV of 5. For calculating the CV, what it has to calculate? Which one it has to calculate? R square. For each of them time, calculate the R square. Means for CV means divide the entire data into 5 parts. Out of the 1 part is for testing and remaining 4 parts are used for training purpose. When you're testing, are you going to calculate RMSE or R square? Which one? That I'm writing here. Calculate the R square. So in the CV, it will calculate every time the R square. And after that, it will identify the best parameter. Can you see here? I'm fitting on the X train, Y train and best parameter. Now it is going to identify first 0.1, 0.2, 0.5, 0.7, 1, 10, 50, 100 and 1000. It will apply one after one for loop. And after applying everything, it is identifying which is the best parameter. Means alpha is equal to 1 is the best parameter, it seems. For the given data set, alpha is equal to 1 is the best parameter. Now let us remove this alpha is equal to 1. I'm removing the alpha is equal to 1. Now it will identify within the given data whichever is the best. Grid search CV means it will identify within the given grid. Within the given grid, it will search which is the best value for the CV. Grid you have to give. You have to give the grid. For which values you have to check, that one you have to give. Just it will apply the for loop over that. That list of values you have to provide. How you are going to provide, that is your choice. Whether you are going to write manually or you are going to write separately some code and that one you are going to share here, that is your choice. Is that clear, guys? Is that clear? Now, for example, let us take like this. Now I'm going to write here while loop, while x less than or equal to 10. Okay. Now L, I'm going to take L value. L is equal to 1 empty list. L is equal to 1 empty list. L dot append of x. So from where it has to start x value means x value should start with x is equal to 0. And each time it should be incremented by x is equal to x plus 0.1. It has to do with 0.1. Now I'm going to apply this one. Now I have got the list of L values. So these are the complete list of L values where I'm having with respect to every time by increment of 0.1, 0.1, 0.1, 0.1, it is adding. Okay. For each value, it is adding the 0.1. First 0, 0.1, 0.2, 0.3. Forget about the 0, 0, 0. Just ignore that. 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, 1.1, 1.2 like this. Now, if you want to make it as a round figure, I'm going to take a round of x. Round function of x. I'm going to apply the round of x up with a decimal of 2. Now you can see here. Okay. Now I'm having the list of values like this. Now you provide this list here. How to provide that list here? L. Just you have to give the L. Automatically, it will apply for each and everything. It will apply for each and everything and it will identify which is the best alpha value is. Best alpha value is 0.9. Since you got the 0.9, still you want to increase more than 10. Huh? Your answer is still less than. So you no need to even try for up to 10 also. You can try up to with respect to this value, you can keep less than only 5. Initially, you can keep for the 5. Okay. For the 5 only, within the 5 only, you're getting the best answer as 0.9 as the best answer. Now, once we identified the alpha value is equal to 0.9. So now I have not given the list of values, right? Manually, I have not given anything. So whatever the values I want, first I have collected into a list and that list I am providing as the input. Now automatically it will apply in the backend for I in range of, for I in the L, for I in L, it is going to apply for each and every value, it is going to apply. After applying for each and every value, it is identifying the best parameter. Right? Now, once I have identified the best parameter of 0.9, this 0.9 I'm going to use and I'm going to decide my final model. Now rebuild once again your ridge model using your best hyperparameter. Now you have got the train R square, test R square, and CV score. Now, if you want to predict on a new data, see here, new data is age is equal to 31. Age of 31, female, BMI of 25.74, children of 0, smoker of no, and region of northeast. This is the input data. Means if you consider this input data as a data frame, this is the input data. For this input data, you have to predict the expenses. What is the data pre-processing we have applied first? In the earlier case, what is the data pre-processing? What is the data pre-processing we have applied? In order to get this model, first we have dropped the region column. After that, we have encoded the gender column and smoker column. If multiple variables are there, then duplicates. If multiple variables are not there, duplicates will not be there. So there is no discussion of duplicates. So here we have dropped the region and we have encoded these two. The same thing I'm doing here. I'm doing the same thing here. First, I'm dropping the region column, followed by gender column. Wherever the female is there, 0, male should be replaced with 1. So automatically this is female. So it will be replaced with 0. And no should be replaced with no, 0, and yes with 1. So here the smoker of no miss, it is going to be replaced with 0. Now after this, now I'm going to get the transform data in this way. Your model, this is your final model. This is your final model. Rebuild the ridge model using your best hyperparameters where you have taken the alpha is equal to 0.9. In this, how many beta values are there? 1, 2, 3, 4, 5 only are there. Means 5 input columns only you should require, not 6. Now what it is going to apply? Whatever the values now you are having here, just it is going to apply this one in this values. Now tell me, what is this values? After data pre-processing, age is 31. Age is equal to 31. Gender, sex is equal to 0. BMI is equal to 25.74. Children is equal to 0. Smoker is equal to 0. Now, substitute the same values in the given equation. In the equation, what is the equation? Beta 1 x1 plus, beta 2 x2 plus, beta 3 x3 plus, beta 4 x4 plus, beta 5 x5 plus, beta naught. Where beta 1 value is 264.48578495 into what is x1? X1 is nothing but age. Here the age is equal to 31. In my case, it is equal to 31. Now this one, 264 point. I'm just opening the calculator and 264, this whatever the exact is there, I'm copying this one in the calculator into 31. I'm multiplying with 31. What is the answer I have got is 8,190 0.59333345. If you want exact value, this is the way. No sir, round figure also okay, miss. 8199.05 plus beta 2. What is beta 2? Minus 113.29 into 0. So this value is going to be 0 plus beta 3. That is nothing but 318.55 into 25.74. So let us calculate that one. I'm substituting in the equation into, that is 25.74, which is 8199.64. And next, beta 4 into x4. What is beta 4 into x4? 0. Beta 5 into x5, 0. Beta naught is minus 12,133. So what I'm going to do first, 8199.05 plus 8199.64 minus 12133.70. Now what is the answer, miss? 4264.99. This is the expected answer. If I predict miss, is that clear? In this way, it is going to do, and it will give the output. Just it will substitute the input data in the given equation, and it will identify the output value. That's it. Yes. If in the given model, is there any overfitting? So if you are having in terms of overfitting, so here, for example, let us take like this 75.9 and 70, and this is 74.6. So it is going to take almost close. It is almost close, not that much, but still, if you feel this one as still as overfitting problem also, you can do with respect to what? Means you can try with the another algorithm. Means, for example, still it is giving the overfitting problem. Sometimes, see, here, whatever the train ask pair is there, before default parameter, for default alpha is equal to 1. Alpha is equal to 1. What is the train ask square, test ask square it has given? For alpha is equal to 1. Default parameter. Default parameter. For default parameter, it is going to give the alpha as 75.9 and this one as 70.08 or something 70.0. This is the train and this is test. And CV. CV is 74.65. This is the CV for default parameter. Now, if you go with alpha is equal to 0.9, it identified the best parameter of 0.9. Now for 0.9 also, it is going to give the same 75.9, 70 and 74.65, same to same. For default also and for alpha of 0.9 also, it is going to give the same. There is no much difference. Now here, for this data set, since it is not applying and no changes in data set, we can't conclude every data set will have like this. For few data sets, for some of the data sets, it may not have that much of impact. For some data sets, it will have very much high level of impact. So your hyperparameter tuning values, either the use of hyperparameter tuning, by doing the hyperparameter tuning, either you will have more accuracy, either you'll have with more accuracy, or at least your time will be reduced. Time is reduced out of these two. Okay, sometimes we'll have more accuracy. Sometimes the accuracy also remains same. It will not increase or it will not decrease. It will be as it is. In that case, at least time will be reduced. In few data sets, this will happen. In few data sets, that will be happen. Now, if you observe the same thing, whatever the logic I have explained now for the ridge model, that is first you have to do the data pre-processing, followed by you have to do the modeling with evaluation. And after that, hyperparameter tuning. And after hyperparameter tuning, whatever the best answers you have got, you have to create the, once again, the model. Now I'm going to upload for you one more data set, a new data set as an assignment. Now for that, if you apply, automatically you'll change the more difference. In that case, you'll observe more difference. In some cases, if it's not applying miss, we can't conclude based on that single one. Is that clear? So that is with respect to ridge regression. Yes, collinearity problem, we have to check only between the input versus input, not between input versus output. Only between two input variables, if the correlation is high, then it is called as collinearity problem. Means here between the two input variables, that is two numerical variables, that is BMI and age. Between these two, there should not be high correlation. Is that clear, guys? Done. So that is the end of the ridge regression. And in the next class, we are going to discuss the lasso and elastic net regression. Right? And some of the students are attending the KVROS at 5 p.m. Some Python class is going on, it seems, right? 4:30 or 5 around. And some of the students are attending, it seems, and they are unable to take the exam at 4 p.m. if I'm conducting at 4 p.m. Is that okay if I go with 11 a.m.? Morning 11 a.m. Is that okay? How many of you are having the problem with morning 11 a.m.? Please raise your hand. Okay. Then what is the feasible time? Few students are going with the, how many of you are having the problem with 4 p.m.? Offline students, none of you are having none of you are going for Python class. Okay, then let us go with 4 p.m. only. Okay. Let us go with 4 p.m. only. Attend, you take the exam at 4 p.m. only as per your choice. Done, guys. So tomorrow the exam will be at 4 p.m. And please go through everything, whatever we have discussed till now. Right? Any questions? Sorry. Yes. No. In the alpha is equal to 1, y minus y hat whole square when you are checking, but alpha is equal to 1 means beta 1 square plus beta 2 square plus beta 3 square, all this also will be added, right? Though alpha is equal to 1 also, still slope squares will be added, right? In the equation. The both are not same. Right? Done. Sir, what will be the process of data science interview? First, we have to send your resume to the company. And in the company, if the resume gets shortlisted, they are going to send one data set to your mail. They'll send a data set and they'll ask you to analyze. If you properly analyze and after replying to this data set, you have to send whatever the analysis or whatever the things they asked in that given problem. And once you share the answer on the same mail ID, once you share the answer, based on that, they are going to do the interview. The next step will be interview directly. Okay. In the interview, the first question would be, how you have approached this problem is the first question. In the interview, the first one, if they have shared you a data set like this, and once you have submitted your answers in the interview, they'll schedule an interview. In the interview, the first question will be, tell me about yourself. I mean, introduce yourself. This is first one. In the introduce yourself, you have to introduce in excellent way. And this is a golden opportunity for you. 100% they are going to ask one question. And this is a golden opportunity. And you have to introduce in such a way that they have to get impressed and they have to deviate according to you. For example, if you say that at the end, in the introduction, at the end, sir, recently I have worked on this project. If you add that word, automatically you are simply deviating them to ask the questions into that project, right? Obviously, if you say that I have recently worked on this project, generally the mindset, what would be there? Oh, you applied recently this one, huh? Okay, what is that project? Next question will be that one only, right? What is that project? And we are going to explain, so this is the project and this one. Okay, how you have done that one? Obviously, the next one will be. So we are going to deviate them according to our way. In that way, we can do that. How we have to do all these things, I will explain in the mock interview sessions. How we have to do all these things, right? Yes. The coding part, just I'm uploading now itself, and please go through the coding part. The same to same in the Lasso and Ridge also same. In the tomorrow's class, I mean on the Monday's class, up to data pre-processing, there is no difference. In the Lasso, first I'm going to try with the alpha is equal to 1. And after that, I'll apply the hyperparameter tuning. And I'll identify the best alpha value. And using that best alpha value, I will close that one. The additional advantage of Lasso regression is it will identify the important features. It will give the beta value. If any unimportant feature is there, it will directly give the answer as 0. This is not important for me. That is the advantage of Lasso regression. So the Lasso regression identifies whichever the unimportant variable. It is going to be useful as the future selection. Remaining everything is common. Up to data pre-processing, not even single line of code, not even single letter also will change. In this data pre-processing, before to modeling, whatever you have done and whatever the train test split you have taken and whatever the random state you have taken, the same thing as it is will be there here. Up to here, there will be no difference. Whatever the records you have used for training purpose, the same records you have to use here also for training purpose. No difference in that. After data pre-processing, the difference starts only in the modeling. In the modeling, you are going to take Lasso. First, you are going to build the Lasso regression with default parameters. And after that, you are going to apply hyperparameter tuning. And you are going to rebuild with the latest hyperparameter, whatever the value you have got. And you are going to predict also same. While prediction also, what you have to do? First, you have to do the data pre-processing. After applying the data pre-processing, then you have to, whatever the transform data is